is your y. Okay, so we know that at point y you have nothing. Right, at point y you have nothing. Okay, then you know that you have stress z is on this line, right? Stress x, we also are aware that stress x is somewhere about here. Okay, so this is your stress x. And then your shear, okay, so these are your shear. So if you look at element rotation, right? So on x is going to be rotating in a clockwise manner, right? So if you look at this arrow, it's going to rotate in a clockwise manner, right? So it's going to rotate in a clockwise manner. So this is your x, and this is your point z. Okay, so you can sketch your mole circle. So I think some of you have know what is it going to look like already. Yes or no? So 1, 2, 3, 1, 2, 2.8. So this is our mole circle. Hey, mole circle, I draw a straight line. Okay, so this is one of our mole circle. So this corresponds to the circle for the what? For the XZ plane, right? And then we can construct another two circle, right? We can construct another two circle. One over here. And then 2, 4, 1 a bit. One over here. Okay. So the other circle, this one is for your YZ plane. And then the other circle over here, this corresponds for your XY plane. Okay. So now what you realize now is that the plane that you're calculating on your exact plane, okay, so this your exact plane is your in plane, right? It's going to generate the maximum what? Maximum shearing stress. Okay, right? And from here, we know that now we can see that this is stress minimum. Now over here, this is stress max, right? So when that's the case, we know that we have to use the criteria where the shear max is equal to the absolute value of stress max minus by stress mean, right? Divide by what? Divide by 2. Right? So now we know. Okay? So this is again, this is just a sketch. Okay? But this is a good, right? We don't know the value, but it's going to be, is the mole circle is going to look like this. Okay? So now, from here, now all we need to do now is calculate the stresses at stress X, the stresses at stress Z. Okay, so now we're going to go for due to the load axial loading. Okay, so let's go for the axial loading first. Okay, so now we come back here, right? So due to axial loading, again we are trying to find the diameter. Okay, so due to axial loading, okay, so let me check. Hold on. Yep, half. Okay. So due to axial loading, stress X will be equal to minus 2,500. Right? So there's an axial load and it's in compression divided by pi c squared. Okay, where c is the radius of the shaft. Okay, so this is your c squared. And then due to bending moment, right? We know that stress X is equal to minus mc over I, right? So this will be equal to mz over izz multiplied by c. So mz is equal, so we calculate our mz, which is equal to 18,000 multiplied by c divided by pi over 4 c to the power 4. So this will be equal to minus, okay, so 18,000, 72,000 minus 72, right, divided by pi c cube. Okay. So from here we can calculate our stress X. So stress X, not calculate, we can come out with an expression, right? So it's equal to minus 2,500 divided by pi c squared. Okay. Then minus 72,000 divided by pi c cube. Okay. And then I'm going to make a common denominator. This will equal to be pi c cube. Why I made into a common denominator? Because later on when we deal with mole circle, it's going to be easier for us. Okay. So this will be equal to minus 2,500 c minus by 72,000. Okay. So this is our stress in the x direction. We know that stress in the z direction is equal to 0. Okay. And then we are going to look at due to the torque. Which is acting on Tx. So we are going to look for the shear in the xz direction is equal to the shear in the zx direction. So this is equal to Tc over J. So the torque that we know is equal to 27,600 C, and the polar moment of area is pi over 2 C to the power 4. Okay, so this will be equal to 27600 times 2. So it's 55200 over pi c cube. Okay. So what we have achieved down here is we are able to calculate. Okay. So what we have achieved down here, we are able to calculate this now. Okay. So I'm going to copy this. All right. So we know that the normal stress is equal to minus 2500 C minus by 72,123 over pi c cube. And then the shear, right, we know that it's equal to 55,200 divided by pi c cube. Okay. So from here, the next thing we have to find is we have to find our stress A and what? And stress B. And we have to ensure that when stress A minus by stress B, right, over 2, right, it has to be less than tau what? Max, or same expression where stress A minus stress B is equal to 2 tau max, or less than 2 tau max, or this expression can be written as stress A minus stress B must be less than stress what? U, right? And this is because in ductile material, tau max is equal to stress U divided by 2, okay, for this relationship. Okay, so where is stress A and stress B? So stress A and stress B we found over here. So over here, this is our stress A at this point over here. Over here, our maximum is stress B, or vice versa. Does not really matter. Okay, and then we also found out from here, right? From by sketching our circle, our tau max is what? It's at the in plane. In plane means what? Exact plane. So exact plane. So exact plane is this plane over here, right? And it's the plane that's on the outer surface is our in plane, because the surface area is at its what? Is at its maximum. Okay. So from here, we know, right? By looking at Mohs circle, we know that tau max will occur in plane. Okay, tau max will occur in plane. So i.e., so therefore tau max is equal to tau max at the xz plane, and then this is equal to tau max in the zx plane. Okay, so now we have to find, right? So the next thing we have to know, we have to find our principal stress. So we're going to find the principal stress stress A and stress B, and we have to use the criteria now. Okay, so we're going to use a criteria where stress U is equal to stress A minus by what? Stress B. Okay, right? So this will correspond to stress Y is equal to stress max minus by what? Stress mean, which is also equivalent to tau max is equal to half of absolute value of stress max minus by stress mean. Okay, right? So we're going to find the principal stress. Okay, we're going to find it. So the first thing we're going to do is we're going to find the center of the circle. So I'm going to get the Mohs circle since we have sketched the Mohs circle. Right, so this is the actual Mohs circle that we have. Right. So we're going to look at the stress average. So the average, so the center of the circle. So as I mentioned before, we're going to focus on the in plane. So you will have stress average is equal to stress X plus by stress Z divided by 2. So stress X is equal to minus 2500 C minus by 72,000 divided by, so if we look at pi C cube, so now it's going to 2 pi C cube. That's your stress. Then we're going to find the radius of the circle.